Yeah, I'm Richard, Linux distribution engineer at SUSE, which is like the most generic job title anywhere. It's like, you know, human at planet Earth. And yeah, I'm going to be talking about some of the stuff. Well, I'm not going to be talking about a distribution for like my first time at FOSDEM ever. Instead, I'm talking about a nice library living underneath. But starting with that, who is responsible for the configuration of a machine once it's deployed? You know. Not Lennart Pottering, although, you know, if you want to point fingers, you can, is it the distribution, is it the upstream, who actually don't get a mention here, or is it the user? Speaking from a distribution perspective, I honestly believe, distributions have a hand in making sure the configuration of the operating system, once it's deployed, is right and sensible. We should be making sure the defaults are sensible, a good out of the Xbox experience, secure, whatever sensible means, really. I mean, it's, open to interpretation. Different distributions have different interpretations. And of course, different upstreams have different interpretations too. And sometimes we don't agree with what upstream have decided are the defaults. But also, upstreams always do interesting new stuff, and that interesting new stuff often requires new configuration parameters to be set, or the sensible defaults change, and somehow we need to get that to our users. But at the same time, some users believe Linux is about choice, or at least there's definitely the choice they have to potentially ruin their system. And they want to configure their configuration the way they want it. And that means, potentially having unsensible choices, or at least, weird ones that make no sense to us. And they're not necessarily going to be paying attention to all of the stuff going on in the distribution, in those upstreams. So they're not necessarily going to know that this default needs changing, this new feature has some nice new flag, just like the system talk we just had with all those wonderful different flags you can put into your systemd unit files. Right now, for a lot of services, a lot of daemons, that's a bit of a minefield. And sort of the typical classical problem is, distributions got a package, we've got some service called foo, there's a config file in etc. The user edits that and sets it up the way they like it, and then a new version of foo comes along, and we want to change the defaults, we want to introduce the new parameters, or there's been some horrific CVE, and we desperately have to make sure that there isn't that setting set by default, and whatever happens, there's some horrific or semi-horrific explosion. There is no perfect solution to this problem at the moment, no matter how we look at it. You can notify users on wikis and stuff, but they don't read it and it doesn't work. Or if you try and find a technical solution, most of us as packages try something like some fancy PostScript where we're, editing with sed and just praying we've got our regular expressions right. And then we get it wrong and the users scream and file bugs saying the distro broke our config. More conservatively, certain packaging tools, especially RPM and sort of Arch, we have these sort of nice helpers where we can, in the packaging tool, back up the user config, install our new user config, and leave their old config as an RPM save file, and then the user doesn't bother noticing that, and they file a bug saying the distro broke our config. Or we flip it the other way around, and we're paranoid and never touch the user's configuration, and we put our new settings in an RPM new file, and then nobody ever looks at it, and then they file a bug, and we just turn around and say, sorry, your setup isn't supported. It doesn't work at all at the moment. It's the hell we've all been living doing distros for so long, and the hell's getting worse, because there's this lovely new trend of atomic distributions, like with OpenSUSE and MicroOS, where this problem gets even more complicated, because like in MicroOS, we have a read-only root file system. A user can't modify that root FS once it's there, but we want them to be able to modify etc, because they need to be able to change the settings. But when we need some way of atomically delivering those new configuration settings that we need on there without messing around with their config, so it has all of the issues plus more, because we can't just mess around on the root file system like we used to. And when we were dealing with some of these issues that cropped up with what we're doing in macOS, we realized there's one really configuration-heavy service sitting on all of our macOS machines, which doesn't give us any problems at all, and it's wonderful, and life is great, and it's systemd. Which kind of shocked me a little bit when I realized it, but yeah, systemd solves this problem really, really nicely. It has this lovely structure of everything's a unit file, and those unit files live in one of two places. The distribution config is meant to live in usr lib systemd system, and that's where all your unit files live, your timers, your services, blah, 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 blah. And then for your user config, every change they make is in etc systemd system, and the two worlds are separated, and we don't have to worry about that. We don't touch etc systemd system, we just touch usr, and all is good. It gets even better, because with systemd services, you also have this concept of drop-ins. Well, like a per service basis, you get a foo.service.d folder, and you can put little drop-in configuration files in there. Those drop-in configuration files can individually override individual lines or parameters of the other config file elsewhere. So and even that is layered, so you can have usr drop-ins and etc drop-ins, and systemd figures out what the right priority is and applies the right one, which is like what we're using with like Kubernetes now. You've got container runtimes and Kubernetes and all these other distro-dependent stuff, and they all want to modify each other's services. So in OpenSUSE Cubic at least, our usr lib drop-ins, we have drop-ins after drop-ins after drop-ins, and then users can put their own drop-ins in, and then you eventually get the right config at the end. So it's great when you've got this sort of multiple layering. And we realized, well, this is cool for systemd services. Why can't we do it for like everything else? Which, of course, is going to need some work. So let's try and make it easy for people. And so Pascal, an apprentice at SUSE, last year, this entire project is like not even a year old. Basically started writing a C library to kind of, first as an experiment to see, can we even do this? And then, like all good experiments, it's got completely out of hand. For basically providing to anybody using this library API calls and functions to be able to do the same kind of configuration layer in their services, in their applications. It's an MIT license, so you can use it for everything. And the two main use cases are literally, both layering sort of an entire config file, like the typical systemd service thing of usr versus etc, or if you really want to be fancy, doing sort of foo.d and drop-ins and layering those two things on top of each other. Like I said, not even a year old, so it's not even this is its first FOSDEM it could ever be at, because it was 26th of April last year we started it. But yeah, we're using it in plenty of places. It's not magic, start with the negative. You need to modify software to have libeconf support. We're not magically taking over other bits of services. And in its current form, it only supports sort of ini-style configuration files where you've got a group, you've got a key with a value, you've got another key with a value. It's flexible in the sense of you can have whatever delimiter and white spaces you want. But at the moment we're only working with these kind of configuration files which form this structure. I'm not going to give like detailed code examples, and the API list is getting longer and longer. But at its core, there's sort of 8 or so core API calls which kind of do all of the work. econf read file reads a configuration file, takes all those key values, and dumps them in a key file for use elsewhere in your application. Reader basically does that, but for multiple configuration files in a directory. So that's what you would use for the kind of foo.service.d equivalent. There's a function for enumerating the groups in there, which can be handy when you're looking for that one config file nested in the one config nested in one group somewhere down the line. Get the keys, and then we have a whole bunch of get value of various types, so you can grab your strings and make sure it's all type same. Grab your write long int and get the correct value of the correct type you expect as you go along. That's all the reading. On the writing side of things, thanks. We've got a bunch of setters for doing the same in reverse, so you can set your configuration back in there. We've got a tool for merging files, so you can literally just two straight files, merge everything together, job done. And all of those API calls are stable, versioned. We're not going to break them at all. That's we promise. Write file, on the other hand, for writing out this to a configuration file. We've got people using it, but it's not yet stable. It's because we're not entirely happy with how it's writing or handling things like the file already being open or already being edited. But it's there if you want to write the file back out to disk. In OpenSUSE land, like I said, this has all kind of gone out of hand, but in a fun, exciting way. OpenSUSE is moving towards using USR for all of its distro config. That's the goal. It's going to take years, but we're moving in that direction as fast as we can. So we want ETC to be considered user data and treated with the same reverence and avoidance as /home or /srv. We don't want to be messing in our users' sandpit. That's ETC should be theirs. We don't want our packages touching it. We don't want our scripts touching it. We don't want to be responsible for breaking anything anymore. So in the case of like systemd, it's already using USR, but for the stuff that doesn't, we're now starting to use USR etc. and basically moving our configuration to there. In the case of libeconf doesn't care about these locations. It's all variables, so you could use it how you want, put it where you want. So this can handle user lib whatever or user etc whatever. It doesn't matter, but for us, we're finding it's easier to move things along to there because it's a one-to-one mapping of user etc whatever to etc whatever. Makes the logic a bit simpler for us. There's a number of examples where we've already got applications moving across to it, like PAM. PAM upstream has libeconf support since 3 or 4 months ago, I think now. So if in OpenSUSE, we've already packaged it up with this. So user etc pamd has all of your PAM configs. Then user config can be an etc pamd. Both get passed at runtime, and etc values always win. Nice, simple, done. The same for Shadow. This is also upstream, which of course they're also using PAM, so it also has their config in pamd. So it's fun that when they're all sharing the same thing and using the same library. But you've also got login defs, and I just realized a typo because that's meant to be user etc login defs. But yeah, the login defs are stored there. etc login defs, can be overridden by users. The etc values always win. That's all done at runtime. And all of the util Linux stuff, this is not yet upstream. I think it's submitted, but there's some discussions about our patch, but we've patched it in OpenSUSE, so all of the SU, login, remote, etc. in OpenSUSE are using this, and using it exactly the same way. But there's exceptions. So Reboot Manager, which is the tool in MicroOS, which basically detects when there is an update pending, well, there has been an update applied, and there is therefore a reboot pending and required to be done. That configuration is really simple. There's like, it's one group, there's like 4 parameters. There's no point doing all this complicated nesting and layering. So in that case, you've just got a nice, simple, straightforward config file, and you can put another nice, simple, straightforward config file in etc. And we just merge both of them at runtime, and we use that unstable write file to just dump it in etc reboot manager conf. And so all the logic in the code for actually reading the configuration file hasn't changed at all. It's still reading the same config file, but yeah, libeconf is doing a little bit of magic before that to move things along. And yeah, we want as many other projects to start adopting this, using it in their own way. We haven't yet done this where you must follow a certain sort of systemd-like or PAM-like approach, where you have to use the same config. We realize upstreams have their own way of, upstream applications have their way of doing configuration. We want to make this as easy as possible to fit in. So you've got the primitives here where you can take libeconf, make our life easier and make your life easier, hopefully. But you don't have to rewrite your entire logic of how you're consuming your configuration in your application. We are thinking of adding more high-level API calls for people who just want to make things even simpler for them in the long run. But before that, we have some concrete plans. Parsing config files is hard, and our parser isn't perfect. So I've been looking at using a much more established configuration file parser, as you know, instead of writing our own and constantly tweaking our own. So Augeus is on our radar. I have some patches that are roughly working, and you know, I'm slowly patching it into all of the API calls. It does a very good job, technically speaking. You know, it's very reliable. It handles far more variations of configuration files than just inis. It also handles those ini files more gracefully, especially those weird ones with weird delimiters and weird white space rules and all that stuff. Yeah, Augeus has figured that all out already. The downside is, though, you know, it does make the dependency tree for libeconf, you know, a little bit heavier than just a nice simple C library that you can plop on and put into everything. And the code is getting a little bit more complex. So this isn't certain. I want to kind of, you know, get feedback from anyone here and see if there's any other options out there, or help doing this. You know, if people think this is a great idea. But yeah, it's a sort of work in progress and the direction we'd like to go, because we realize that just doing ini files is somewhat limiting for this idea. And Dominic, is Dominic here? Nope. Dominic, another one of our apprentices, he's working on econf tool, which is basically aimed to be sort of a generic helper tool for the idea being, you know, an application's started using libeconf. That now means you've got configuration files in USR, configuration files in etc. How does a user know what parameters are actually being applied, when, how? So econf tool is sort of a generic helper of, you know, taking their default logic, you know, like ideas like, yeah, econf tool pamd, what your config is, done. You know, give a list out there, and a bit like systemctl with like systemctl edit, you know, be able to edit the config and it'll put the right snippets in the right place and make your life a little bit easier. This is just the beginning. If people like this idea, you know, there's obvious things we could do to improve. You know, different file parser being the one that I already mentioned, but also language bindings. Not everything is written in C. So sadly, especially when it comes to Go. But yes, if people want Go, if people want Python, if people want Rust, you know, this needs to be something used in as many places as we can. You know, we're not just going to start here, you know, stay here, but we can't do everything alone. So, you know, if you like this idea, you know, the code is open. It's MIT. Contributions are welcome. Changes are welcome. Features are welcome. You know, please help, enjoy, start using it, start putting it in your distro. That's why I'm here, basically. And with that, I think I've managed to squeeze this into 20 minutes or so. So there is just a bit of time for questions at the end. Yes, sir.
In the API, I saw the first one you had was read config file, something like that.
Yeah.
Why is that singular read config file? Is the whole idea that it reads all the files and all the drop-ins and does the magic behind the scene, or did I get that wrong?
So why is the read file just a singular file? Yeah. That's because there are definitely cases where you just have one config file. For the cases where you have multiple in a directory, that's why we have the readers config, the readers API call. And readers just, you know, reads the directory and read files all of the contents of that directory.
So does the programmer of this libeconf have to go through? I understand that the idea is there's the user and there's the etc and there are the drop-ins.
Yep.
And all this, and I would have expected all this matching and merging happens behind the scenes, or does the user of this libeconf have to do that?
The application developer who is patching libeconf support into that application has to do that. So the user doesn't, but, you know, libeconf is there to be, you know, consumed. Yeah. So at the moment, yes, you know, we are planning on adding, you know, higher level API calls which, you know, have opinionated views on how you do that matching and merging, which will make their life easier. You know, that's, you know,
so, but at the moment, my stuff lives under user etc foo.
Yep.
And there is under something under etc foo, and I have to order the drop-ins and everything. I have to do that manually. Yeah,
you have to do that manually. Yeah, but like the reboot manager example is kind of like a nice simple one. You know, it's one config file, so you know the config file now lives in two places. You merge it. It's yeah. You know, not everybody has complicated stuff like PAM. Yeah.
Yeah, you said you don't have the path anywhere.
Yep.
So I suppose you welcome the haiku port, maybe?
Yeah, absolutely. Yeah.
Yeah, you might want to look into how we support relatively, so you might want to have a look at how they did it.
That in Haiku. Okay, yeah, we will look at that. Thank you. Cool. Yep.
Do you handle merge conflicts?
No, we do not handle merge conflicts. So the moment with the current calls we have, you've got, with that merge files, for example, you're declaring one is going to override the other, so by how you order it, and there's no magic there. So for the more complicated stuff, you could use those primitives to do fancy stuff with handling merge conflicts, but yeah, no.
Is there a standardized and simple way to display all the config files?
There's no standardized and simple way of displaying all the config files. That's kind of what the econf CTL or econf tool. Sorry, we was called econf CTL a week ago. Econf tool is looking at doing is sort of giving you a sort of standard way of doing that. Yes.
Do you plan to port systemd over?
Do you kind of? I have a feeling that it doesn't really make sense to port libeconf, systemd to use libeconf. They're doing it fine. We wouldn't really have anything there. Yeah.
Another question about systemd. Did you reuse their code or?
No, this is all completely fresh. No recent code. No. Sorry, but just repeat the question. The question was, did we reuse any of systemd's code with us?
Character encoding?
Hmm?
Character encoding is UTF binary.
Is it UTF? It's binary.
Different encoding.
How? At the moment, it's just UTF. But it's a bit basic at the moment. Yeah, it's a bit naive at the moment. We admit that. Yeah.
So how many different upstreams have you patched to use this stuff?
Most of them are in this slide. I think I might have missed one or two, but this is kind of where we are after a year. So the question was how many upstreams have we patched?
What do those upstreams think?
So most of them have been like the question was what do they think? Most of it has been like surprisingly, wow, this is cool, great, merge in, done. So util Linux has been like the only one where there's been sort of questions, feedback, like improvements juggling around. The rest have been like, here's the patch, fine, done, in. Of course, in the case of Reboot Manager, we are the upstream, so that we cheated, but yeah. Next question, yes.
In your Reboot Manager example, given that you write the merge configuration back to etc.,
Yes.
how would the distribution and shipper change to the default?
How would the distribution shipper change to the default in the case of like Reboot Manager where we're writing it out? Yeah, we wouldn't. It's in the case of Reboot Manager, because we're the upstream as well, we know we're like probably never going to do that, and if we do, like the config file's simple enough, so we'll still hack around it the old-fashioned way, which it's a rod for our own back. We'll do it properly one time, but in that case, it's mainly for adding new configuration files, because Reboot Manager is in a kind of similar state of development, relatively new, moving relatively quickly. So they're just using libeconf makes our life way easier for adding that new thing out to existing systems. Plus also with Reboot Manager being like a really, that's definitely something where you don't want to mess with what the user's already decided. They've got their policy for how they want their system rebooting, and that like those core parameters are basically that right now. So the chances are, even if we change the default, we're not going to change the default time your system's booting. You've picked it, you're running it. It's done, dusted. You would hate us if your machine started rebooting at the wrong time.
You provide any tooling like the distribution to move to like this system in the way that you compare what the distribution would provide, how the user modified, and then to move like only the diff to the user stuff and the system default.
Yeah. So the question is, do we provide any tooling to kind of help people move to this approach? We don't. econf tool will do some of that for users, because you'll have that there where econf tool will be showing this is coming from the distro USR. This is what you've got in etc. So this is what the runtime use is. We could look at adding that or working on that for making sort of the transition easier. But we have found, because we're going to this, every upstream app is different. They've implemented their configuration differently. They're consuming it differently across their entire code base. And we're not trying to force everybody to doing everything exactly the same way. So this is sort of trying to be that middle ground of it's flexible enough that you can patch it in so your config can be split and layered, but you don't have to, don't have to do everything exactly the same way. Time's up. I'm sorry, but I'll be outside so we can catch you later. Thank you very much.